In this video we shall discuss how to use caching views and tables to select data. First we have to start with the next disclaimer. All samples here are provided for educational purpose only, and approaches described in the next several slides may drastically decrease your database performance if used improperly. So in the first task we have to create a view to speed up the retrieval of the following data: total books count, taken books count, and available books count. This is the expected result, and such data should be produced by execution of such a simple query. Select everything from our created view. Let's start with MySQL. This DBMS does not support materialized views, so we have to use table here. And that's why we have to create such a table, books statistics. This table should store total number of books, number of given books, and number of books available in the library. To ensure the correct results, first we have to clear the table to execute truncate table statement. Then we have to produce the initial dataset and put that data in our new table. The only way to update caching tables in MySQL is to use triggers. We shall talk about triggers later in our course. So we have to drop old versions of our triggers. Then we have to switch the query delimiter to tell MySQL where the query inside the trigger ends or where the whole trigger ends. And let's create our triggers. We shall start with before insert one. It will react to book insertion. For each new book, we shall take the quantity of that book and add it to the total number of books in the library. And as the total quantity of books in the library had changed, we have to recalculate this value of books available in the library. Also, please pay attention to this note. In MySQL, triggers are not activated by cascade operations, so you'll have to create more triggers yourself to cover all situations of data modification for this task in MySQL. The next trigger will react to books deletion. Once a book is deleted, we have to take its quantity and subtract it from the total quantity of books in the library. Then we have taken into account active subscriptions for that book and subtract that information from given books count. And then we have to recalculate the information about books available in the library. The next trigger will react to books update. To get the new total books count, we shall take old value, subtract the old quantity of a modified book and add the new quantity of a modified book. And then we have to recalculate the number of books available in the library. After we've finished with all triggers, we have to return the delimiter back to this value. As this data depends both on books information and subscriptions information, we have to create several triggers on subscriptions table. So we delete old versions of our triggers, we switch the delimiter, and we start with before insert trigger. As this trigger is executed for each inserted line, we have to find out if a new subscription is active. If it is, we have to decrease the number of books available in the library and increase the number of books given to subscribers. Then we have to create a trigger reacting to subscriptions deletion. If a deleted subscription was active, we have to increase the number of books available in the library and decrease the number of books given to subscribers. And the final trigger here should react to subscriptions update. We have to find out if a subscription has changed its state from active to inactive or from inactive to active. Based on this information, we set our delta as -1 or as +1. As the total books count does not depend on subscriptions update, we have to recalculate only these two values. Now let's proceed with Microsoft SQL Server. Yes, this DBMS supports materialized views, but there are a lot of limitations, so we have to use caching tables here, as with MySQL. So here's our table for statistics about total books count, about given books count, and available books count. As with MySQL, first we have to truncate the table, and then we have to fill this table with initial data. Then we use the same approach as with MySQL. We create triggers. First we have to drop old versions of our triggers, and then we have to create new ones. This trigger will react to books insertion. Unlike with MySQL, where a trigger is executed for each line of a table, in Microsoft SQL Server any trigger is executed for the whole statement at once. That's why we have to perform some additional operations here. We have to find out the total quantity of copies of added books. And then we use that information to update our total and rest count. We have to use these two queries, the first and the second, because Microsoft SQL Server does not allow to modify a field value and immediately use the new value in a single query. This trigger should react to books deletion. We have to decrease the total amount of books in the library by the sum of copies of all deleted books. Then we have to decrease the given books count, and we only have to take into account the information about our deleted books if they were used in active subscriptions, not in inactive ones. The next trigger will react to books update. To calculate the new total books count, we have to take the old total books count, then we subtract the sum of old quantities of all changed books, and then we add the sum of new quantities of all changed books. And as this data depends on subscriptions table also, we have to add some more triggers. First we drop old versions of our triggers, and then we create a trigger on subscriptions table that reacts to subscription insertion. Here we have to find out how many active subscriptions were inserted, and we use that data to modify the rest and given values in our statistics table. If a subscription is deleted, we have to calculate how many subscriptions were deleted, and we use that value to modify our rest and given values. And the last operation we have to react to is subscriptions update. When a subscription has changed its state from inactive to active, that means that a book was taken, and we count all such cases. If a subscription state changes from active to inactive, that means that a book was returned, and we count all such cases. Then we use this information to find out our final delta here, and we use that delta to update our statistics. Now, before you begin executing tasks for this video, it's a good idea to test all those triggers performing corresponding operations, so please create those triggers on your DBMS and investigate their behavior. And now let's see how simple the solution for this task for Oracle is. That's all, that's the whole solution. Here we only have to drop the old version of our materialized view, and then we have to create the view itself. This is the query we've already seen for MySQL and Microsoft SQL Server, and we've used that query to initialize our caching table. Here this query is the view body. Then we only have to tell the DBMS to create that materialized view, and we have to set several parameters about the update of that view based on a timeout. Unfortunately, due to some specifics, we cannot use that refresh fast on commit mode here. That's bad, but we still may use this approach to tell Oracle to update this view automatically. And once again, it's a good idea to test this view performing all corresponding operations on your local copy of Oracle. In the second task, we have to create a view to speed up the retrieval of subscriptions data in human-readable form. It asks with books names, subscribers' names, and so on and so on. This is the expected result, and all this data should be produced by execution of such a simple query. And you see that there are no IDs of subscribers here, but names, and there are no IDs of books here, but titles. As MySQL still does not support materialized views, we have to use table here. So here is our table, subscriptions ready. Here we see the subscription ID, the name of a subscriber, the title of a book, the start and the finish date of a subscription, and the information about if the subscription is active or inactive. Then we have to clear the table and put the initial data into it. Like with previous solution, we have to use triggers here. As we do not store IDs of subscribers and books in our caching table, the only way to keep the data up to date is to recalculate the whole dataset each time. So we have to do the following. We have to drop old versions of our triggers, we have to switch the delimiter, and then we start with trigger reacting to books deletion. Pay attention that insertion of new books or subscribers does not affect the result, so we only need delete and update triggers here, but not insert one. And this is our delete trigger. First, we have to delete all the data, and we cannot use truncate operator inside a trigger, because truncate is non-transactional operator in MySQL. That's why we have to use delete operator here. And then we only have to calculate the whole new data set and insert it in our caching table. With books update, first we have to check if a title of a book was changed. If it wasn't, we may skip the whole operation here, but if it was, we have to perform the same operation as in the previous trigger. We have to delete all data from our table, then we have to calculate the new data set and insert it into our caching table. And of course, we have to remember to switch the delimiter back to this semicolon. As our final data set contains information about subscribers, we have to put several triggers on that table also. And we shall start with a trigger reacting to a subscriber deletion. Like with previous triggers, first we have to delete all data from our table. Then we have to calculate the new data set and we insert it into our table. The next trigger reacts to subscribers update. We have to check if a name of a subscriber was changed. If it wasn't, we do not have to do anything here. But if it was, we have to delete all data from our table, we have to produce the new data set, and then we insert that new data into our table. Unlike with books and subscribers table, for subscriptions table, we have to create all three triggers. It asks for insert, for update, and for delete. Let's drop old versions of our triggers, switch the delimiter, and create the first trigger that should react to subscriptions insert. Here we may optimize our query. We select only information about new subscriptions and then we insert only that new information into our caching table. When a subscription is deleted, we only have to find out the ID of that subscription and then we have to delete that information from our caching table. And if a subscription is updated, we may also use some optimization here. We take into account only the updated subscription, then we find out all the data about that subscription and we use that data to update our caching table based on those IDs. Now, like with previous solutions, it's a good idea to test all those triggers yourself. For Microsoft SQL Server, the solution is simple. We have to drop the previous version of our view, then we have to create the view and we are using this query that will produce that result. To make this view a materialized one, we have to execute the following statement. We have to create unique clustered index on that view. And that's all. From now on, Microsoft SQL Server will update the information inside this materialized view once some of these tables are changed. And here is the attentiveness test for you. Of course, this information is about Oracle, not about Microsoft SQL Server. Such attentiveness tests are spread across our course to keep your attention. And with Oracle, the solution is also simple. We have to drop old version of our view and then we have to create our view. Here we tell Oracle to make our view a materialized one. Here we tell Oracle to update our view based on some timeout. This query produces that result, and that's generally all. From now on, Oracle will automatically update this data in our view based on that time periods. And once again, please test all these solutions yourself, performing corresponding operations on your DBMS.